Now we're going to look at our piecewise functions again, and here we're going to look at how we go about graphing a piecewise function. Recall a piecewise function is where we're taking two functions and putting them together to make one function. And here notice the first part of our function is 1 minus the quantity of x minus 1 squared. Now because this is squared, now we know that we're going to be looking at that parent function which was x squared, so we know that we're going to be looking at part of a parabola is our x squared, okay? And then we have the other part of our function is the square root of x minus 2. Well, remember the square root function is half of a parabola on its side. So if we just had the parent function here, the square root of x, then that's going to look like kind of this half of a parabola laid over on its side. So what we're doing is we're taking part of each of these functions and putting them together, and it's all going to be based on the restriction. So if we look here at the first function on top, the restriction is x must be less than or equal to 2. So let's go about graphing or coming up with some points to graph this part of our function. And I'm just going to make a little chart just like you have in the past. And I'm going to pick values of x, and of course I want to pick values of x that are less than or equal to 2. So I'm going to start with 2. And if we plug 2 in, you're going to get 2 minus 1 is 1. 1 squared is 1. And 1 minus 1 is equal to 0. And then I'm going to pick 0. 0 is less than or equal to 2, so if I pick 0, we're going to end up with, well, let me go ahead and pick 1. If we pick 1, that's still less than or equal to 2, so 1 minus 1 is 0, and then 0 squared is 0, so then we end up with 1 minus 0, which is 1. And now if I plug 0 in, we get 0 minus 1 is a negative 1. Negative 1 squared is 1, and 1 minus 1 is 0. So there's a few points, and again, we know it's going to look like part of our parabola here. And then I want to look at some points for the second part of our function, which is this square root part. So here, if I pick some points for x, now the x values have to be greater than 2. So I'm going to pick 3. 3 minus 2 is 1. The square root of 1 is 1. And notice now I'm going to jump up here and pick 6. Now the reason I picked 6 is because now 6 minus 2 is 4. I knew that if I took 2 away from 6, I get 4, which is a perfect square. So when I take the square root of 4, the answer is 2. That way I eliminate the having to worry about graphing a decimal. Now, because I know what the graph's going to look like, I know it's going to have kind of this curve shape. That's all the points that I'm going to pick. I mean, you could certainly go here and pick some other values for x and look at a better representation. Now, if I plot these points, we know that when x is 2, y is 0. So when x is 2, when x is 2, y is 0. And then at 1, 1, when x is 1, y is 1. So we're going to go up 1. And then when x is 0, y is 0. So then we have 0, 0 here. Whoops. And this should be 1. When x is 1, y is 1. Now, what's happening here is we have a parabola, and because of this negative sign, our parabola is actually opening downward. And I know that this is going to look something like this. Now, we know that x is less than or equal to 2, so I'm going to stop here at 2. So the only part of the graph I'm looking at is this part over here. Now, we know that if we were to graph this function 1 minus x minus 1 squared, if you were to put that into your calculator, you would get this entire parabola like this. But because of the piecewise function, we're only looking at values of x that are less than or equal to 2. So that's going to eliminate this part of the graph. Now, once we cross over greater than 2, then we're looking at the square root function. So when x is 3, y is 1. When x is 6, y is 2. And I know the graph's going to go something like this. Again, that's because of this square root function. And the more familiar you come with these different parent functions we talked about before, the easier it's going to be for you to graph these other functions. Now, am I missing something here with this second part of the graph here with the square root here in green? Now, if you notice, a lot of people get confused here. It says x is greater than 2, so I pick 3. Well, what about all of these other values that are from 2 to 3? So like 2.1, 2.2, 2.3, 2.4, 2.5. Well, all of these decimals in between 2 and 3 are still greater than 2. So even that means this graph would continue all the way down, but it wouldn't include 2, but it would be very close to it. And because of the other function, it actually fills that in. So, for example, if we were just looking at this bottom function, and I want you to understand this here, what's going to happen at 2, what's happening here is, here's our graph. Now, once we get here to 2, this graph would come all the way down to here, but it's not including 2, so we would have an open circle. That would be the graph here of the square root function. Now what's happening is the function on top, it's coming along and it's going to go up and then it's going to go down and it includes 2, so therefore it's going to fill in the circle at that point. So that's why we have a dot here at 2. Okay, so we need to be careful here when you're looking at when is the number included part of the function or it's not included. So this here is the graph of this piecewise function. So as we trace along here for values that are less or equal to 2, we end up with this parabola going down. But as soon as we hit 2 or greater than 2, we get the square root part going in this direction. Now, it'd be nice if we could put this in the calculator, so I want to look at how could we enter this piecewise function into the calculator. Now, the only thing is it doesn't really indicate some of these closed and open circles, but we can actually put this into the calculator. So if we go to the calculator, we're actually going to go to y1, and I'm going to write this down for you first. You would have y1, and we're going to put parentheses, 1 minus parentheses x minus 1 close parentheses squared, and then we want to close the whole thing in parentheses. Then you're going to open another parentheses and type in x is less than or equal to 2. So that's the first part. Then you're going to go into y2 and we're going to type in parentheses the square root of, and this probably is going to be in parentheses as well, the x minus 2, because we're telling the calculator we're taking the square root of x minus 2, and then you want a parentheses around the whole part of the function, and then we would have another parentheses for x is greater than 2. So this is what we're going to type into our calculator, and hopefully the graph's going to look very similar to this here. So going to the calculator, if we go into y equals, then we need to type parentheses 1 minus parentheses x minus 1, close the parentheses, we want to square that, and then we want to close the whole thing in parentheses. We're going to open another set of parentheses, and then we're going to type in x. Now, where do we have the less than or equal sign? Well, you're going to hit this second function button, and then here the math key, which is activating this test. So second function, math. And down here for number 6, you see less than or equal to. So we get x is less than or equal to 2, and then we're going to close the parentheses. So there's y1, and if we hit enter, we go down to y2 and kind of do the same process, parentheses, square root of x minus 2, and then we want to put that whole square root in parentheses, and then we open our parentheses and we're going to type x and then greater than 2, so that goes second function, math, number 3 is greater than 2, and close parentheses. All right, at this point, I'm going to hit zoom, number 6 is standard, and hopefully we'll see our graph. And there we see our parabola come up, and then we have the square root function. So here I'm actually going to change the window, and I'm going to go from on the x-axis, let's say from x minimum, let's go -6 to +6, and then for our y values, I think we could change our y's to -5 to 5. And that gives a little bit better of a zoom in of the graph. So again, here you see your parabola come up, okay, and then once we get to 2, we have the square root function here going up to the right. All right, so this function here has 3 different functions that we're looking at. And again, I'd like you to pause the video and see if you can work this out on your own by hand, and then maybe you can use your calculator to verify and check your answers, and then you can continue the video to see if you match my answer. So if we look here, the first function we have is 2x plus 1 for values of x less than or equal to -1. And this first function we know that hopefully is going to be a straight line that has a slope of 2. So we're looking at just a straight line that has some slope of 2 here. So if I pick a couple points, and all we need to know are 2 points to graph a line since it's straight. So we're looking at values of x that are less than or equal to -1. So I'm going to start with -1. If we plug in the -1, we get -2 plus 1. So we have a -2 plus 1, which would be -1. And then if we pick something else less than or equal to -1, we could certainly pick a -2, and we would have a -4 plus 1, and -4 plus 1 would be a -3. And I could continue to pick more values, but because it's a straight line, all we need are the 2. And if we look at the second part of our function here, we have 2x squared minus 1, and because of the x squared, we know that we're going to have some type of a parabola, and we're only going to look at part of the parabola for where the values are from -1. So here your x is greater than -1, but x is less than or equal to +1. So once again, we could pick a few points here. And if x is greater than 1, then we could certainly start with 0. And 0 squared is 0 times 2, so we get a -1. And then since it's equal to 1, we could always pick 1. So 1 squared, so you get 2 times 1 is 2, and 2 minus 1 is 1. All right, and then if we move on to the third function, and again we have x squared, so we know that we're going to have another part of our parabola. And I know because this is negative, our parabola is going to be opening down. So it's going to be part of this parabola that's opening down where your x value is greater than 1. So if we pick a couple values here, for x greater than 1, we could certainly pick 2. And we would have 2 squared, which is 4. So 1 minus 4 is a -3. And if we pick another value, let's say 3, we would have 3 squared, which is 9. 1 minus 9 is a -8. Now, you probably want to pick a few more values here for the parabola, but I know what the graph's going to look like, so I'm only going to pick those 2. So now if we try to look at a rough sketch of this graph, Let's see what we come up with. All right, so if we plot the first one here, our straight line, we have the point -1, -1, so -1, -1, and then we have -2, -3, so over 2 and then down 3. So there's our straight line. All right, then we have our parabola here. So we have 0, -1, so at 0, we're down to -1, and then at 1, over 1 and up 1. All right, now I do want to point out, if you notice here for the graph, I started at 0, but really we're looking at values that are greater than -1. So again, that means I need to look at all the values that are from 0 all the way to -1. So I need to look at including all of these decimals right in here, and that's going to be part of the parabola at this point. Now, to help out with that, what I suggest is, we know that we can't really plug -1. Now, keep in mind, we know that we can't plug -1 here into this function. But what happens if we plug in a -1? What do we get? Well, if you plug in a -1, we're going to get -1 squared, which is 1. 2 times 1 is 2. 2 minus 1 is 1. So if we were able to plot this point, that says we would go -1 up 1. And that point would be right here. Okay? Now, that means I'm looking at our parabola that's going to go all the way up to that point. So in other words, we can't really pick this point, so I'm going to put an open circle here. So the parabola then would continue from this point all the way down here and then up to our other point. So even though we can't plug -1 here into this function, I'm going to plug the -1 in so that we can simply get a location in that point, so that I know my graph is going to go all the way to that point, but there would be an open circle there. Whereas on the other end of the graph, because it is less than or equal to, we can have a filled in circle over here at 1 and 1. So there's the graph of our second function. And then we need to look at the other graph in green, 1 minus x squared. So we're looking at values where x is greater than 1, and we pick 2, -3, so that means we're going to go over 2 and then down 3. And then of course we would have 3 and down -8, which would be way down here somewhere. And once again, I want to do the same technique that I did before. I know that we can't pick 1, but if I pick 1 and plug it in, we're going to get 1 squared is 1. 1 minus 1 is 0. So at 1, 0, over 1, and then 0, we're going to have an open circle, and then we could continue from there the graph of our parabola that would open down in this direction. So we would have, instead of having the whole parabola, you're just going to get this part of it. So again, we would have an open circle. So as we're going from left to right, we have our straight line until we get to -1, and then -1 is part of the straight line. And then for values that are greater than -1, we jump up here to the red part of the graph, and we have our parabola that opens up, and it goes all the way over to where x is 1, and we have a solid circle, but anything greater than 1 jumps down to the other function in green, and we get the bottom part of our parabola. So of course this line over here would continue down to the left, and our parabola would continue over here down to the right. So hopefully when you put this into your calculator, or you did this by hand, you ended up with a graph similar to this. Now if we look at using the calculator, we would do kind of the same setup. We would have for y1, we would type in 2x plus 1 in parentheses, and then you would put parentheses x less than or equal to -1, and that would all be in parentheses. And then for y2, we would type in 2x squared minus 1 in parentheses. Now the other part here that we have -1 less than x, x is less than or equal to 1, the way we're going to type that in is -1 is less than x, and x is less than or equal to 1. And all that's going to go in parentheses. And then for y3, we would type 1 minus x squared, and then x is greater than 1. So if we quickly type this into the calculator, we would end up with, let's see, clear out our previous equation. So we're going to type in for y1, parentheses, 2x plus 1, close parentheses, and then we're going to type in our parentheses x, second function, math, less than or equal to, which is 6. So x is less than or equal to -1, close the parentheses, and then we're going to go down to y2. And we're going to type in parentheses 2x squared minus 1, put that in parentheses, and then our second set of parentheses, we're going to type in -1, and then we want less than x. So we would go second and math, number 5 is less than x, and then you're going to go for second function math and scroll over to the top here to where it says logic, and then you would select number 1 for and. So -1 is less than x, and x second math is less than or equal to, which is number 6 again, +1, and close all of that in parentheses. And then you would type in your third function, parentheses, 1 minus x squared, close parentheses, open parentheses, x second math greater than, which is 3, 1, and close parentheses. So hopefully we've typed all these in correctly. And again, I would start with zoom 6, which is zoom standard. And you notice we have our straight line, and then we have our parabola here, and then the other parabola going down. So if I zoom in a little bit here, I can go from maybe -5 to 5 on the x, and then on the y, let's try the same thing for the y, -5 to 5 on the y-axis. So you can see the line comes up, and then there's a jump. We get up to the parabola, and then we have our parabola here at the bottom right. Now, this is really great with the calculator. The only problem is, notice here, it doesn't show you the closed circle and the open circle. So this is where you would need to know how to do that on your own. So whereas we have the solid dot and the open circles here, you would need to know how to indicate that. And you can simply determine that by looking at whether the value is less than or equal to when you plug it in, or whether it's strictly less than or strictly greater than. So hopefully this gives you an idea of how to go about graphing your piecewise function. Make sure you practice this by hand and also experiment with using your graphing calculator.